Hi and Assalamualaikum. Today I want to explain for this question. This question is from the source follower configuration. Let me take a look into very detailed question. For the source follower configuration as shown below, determine question A Q point, which is IDQ and VGSQ. B. Input and output impedance Z in and Z out. Voltage gain AV. D. AVL and AVS if RL is 2 kilo ohm and RC is 1 kilo ohm. Even though in the question, in the figure here, there is no RL and RC, but the question is here. So you need to add this later. Okay. For the question A, okay, we need to do the DC analysis first. Because IDQ and VGSQ can be solved during DC analysis. Okay. The information that given in this question is IDSS, VP and RD. Okay. So for the IDQ and VGSQ, okay, recall back the IDQ, which is the equation, Shockley equation. Okay, this is for the device. And from the network is VGSQ. Okay, the Shockley equation here. Okay, we insert the given value here, IDSS and VP, into the Shockley equation, IDSS and VP. So there is unknown value, VGSQ and ID here. So we get the first equation. Then for the second equation is the network equation. Okay, for the VGSQ, you need to derive it from the DC equivalent circuit. You must change the original circuit into DC equivalent circuit. Okay, so from here, this is the VGS from here. So we get inside this loop. So positive VGS plus IDRS equal to 0. Positive VGS plus IDRS equal to 0. And then we get VGS equal negative IDRS and insert the RS value 2.2K in this equation. So this is equation number 2. Okay, we have two equations right now. So substitute equation 2. Equation 2 is the VGS inside the ID. Okay, then we solve it. Okay, be careful when you are using your calculator and when you have when you expand this equation. Okay, make sure that you get this equation correctly. Okay, this is ID equal to 9 milli minus 8.8 ID plus 2152.08 ID squared. Okay, then we have to set this equation become to 0. So this ID I bring to the right side. Okay, because we have this another ID. So it become negative 8.8 ID minus 1 ID. It become 9.8 ID. Only here is the difference because this is 0. So this is the final answer for the equation of ID. Okay. Then you need to solve this equation using quadratic equation here. This formula. Okay. Then when you insert and you calculate, we get this value. Okay, and finally, the answer is 3.28 milliampere ID1 and another one 1.28 milliampere. Okay. Next, we have to calculate the VGS. So we have to VGS using the equation number 2. This one. Okay, insert to this ID. This ID and this ID. So I get VGS1 is negative 0.22 volt. Another one is negative 2.82 volt. Okay, remember that here must be negative. Why? Because we are using FET. Okay, so VGS we get negative value. Remember this transfer curve. The VP is in negative and this is IDSS. So actually your VGS should be below than VP, smaller than VP. Okay, so this is on area and this is off area. So VGS Q must be somewhere here. So when we compare with VP, our VP is negative 4.5. So the value that less than VP is VGS2. So now VGS2 become VGSQ. Okay, means the Q point is around here, somewhere here, the Q point. So we get this answer.